The topic is quadratic functions. You need to remember that standard form is f of x is equal to ax squared plus bx plus c. If it's not in this form, you need to put it in that form. Okay? Set equal to 0. All right? If a is a number greater than 0, then your function is going to open upward. Okay, in other words, if this number here is positive, then you're going to have a parabola that opens up like this. If that number a is less than 0, in other words negative, then it's going to open down like this. Okay? For the equation of the axis of symmetry, as long as we have it in standard form, then we will be able to do this part real easily. It'll be the fraction of negative b divided by 2a. Okay? To find the coordinates of the vertex is either your minimum or your maximum. Okay? You're going to take the x-axis of symmetry that you just got and you're going to plug it back in to your function to figure out what the y-coordinate is. Okay, your y-intercept is really easy. It's 0, c. To find the roots, you're going to factor it just like we did in the previous lesson. Find out where it crosses x. Okay, example number 1. For the function f of x equal x squared minus 9, find the following. Since this is not in standard form, we're going to set it to standard form. F of x is equal to x squared plus 0x, since there's not any x terms, minus 9. Okay, now I can look at it real easily and tell a is 1, b is 0, and c is negative 9. Okay, the axis of symmetry, negative b divided by 2 times a. Okay, since 0 is neither positive nor negative, it's going to be 0 divided by 2 times 1, which is still 0. X equals 0 is the vertical line of symmetry. Okay, so the vertex is going to be x equals 0, and we're going to plug that back in. 0 squared minus 9 is negative 9. Okay, the y-intercept is 0, c, since c is negative 9. Okay, if you'll notice in this example, the vertex and the y-intercept happen to be the same point. This is not always going to be true. Okay, the roots of the equation, where does it cross x? Since we have the difference of two squares, okay, x plus 3 times x minus 3 is going to equal 0. So x is going to be equal to negative 3, and x is going to be equal to positive 3. So negative 3, 0, and positive 3, 0 is where it's going to cross the x-axis. Okay, if you remember from our function worksheet, the parent function here is f of x equals x squared, and the domain for that parent function is all real numbers. Okay, it's written like this, or you could say negative infinity to positive infinity. Okay, the range, however, is going to be specific to your problem. Okay, my vertex has a minimum value of negative 9. Okay, so my range, if I look at the sketch of that, my parabola is never going to go below negative 9. Okay, so y is always going to be greater than or equal to negative 9, or you could say from negative 9 to positive infinity is the range. Okay, in the sketch, just make sure you include your minimum number, your vertex. Okay, we've got negative 3 and positive 3, and the y-intercept happens to be the same as the minimum here. So those are the same. Okay, the next example for the function f of x equals negative 2x squared plus 7x plus 4, we're going to find all of those different parts of the parabola. Okay, I'm going to start off by labeling a, b, and c. Okay, this is in standard form, so A is equal to -2, B is +7, and C is 4. Okay, the axis of symmetry, -b divided by 2 times A. -7 divided by 2 times -2, that gives me -7 over -4, which equals +7 over +4. Remember, your axis of symmetry is always a vertical line. Okay, the vertex, if we start off with 7/4, we're going to plug that into the equation. -2 times 7/4 squared plus 7 times 7/4 plus 4. That's going to give me -2 times 49 over 16 plus 49 over 4 plus 4. Okay? The -2 will divide into the 16 8 times. Okay, so that's going to give me -49 over 8 plus 49 over 4. And I'm going to write this whole number as a fraction, 4 over 1. Okay? So I'm going to need a common denominator, and 8 is going to be the common denominator. Okay, so the first one's good. Plus some number over 8 plus some number over 8. Okay, in order to get 8 here, I'm going to have to multiply times 2. Okay, and that's going to give me 98. And then I'm going to have to multiply 4 times 4. Or I'm sorry, times 8. And that's going to give me 32. Okay, at this point, don't forget that you need to follow our order of operations. Okay, we started here. Here's the next step. There is a lot of steps to this, but if you take it slow, you'll get it right. All right, so -49 plus 98. Okay, is 49, and then 49 plus the 32 is 81. So we end up with 81 over 8. Okay, and our vertex is 7/4, comma 81 over 8. Okay, it's a good idea here to know what your decimal equivalents are so that you can estimate where it needs to go on the graph. Okay, if I divide 7 divided by 4, I'm going to get 1.75, and 81 divided by 8 is 10.125. All right, the y-intercept, remember the y-intercept is going to be 0, comma, whatever c is. C is 4, so 0, 4 is where the y-intercept, where it's going to cross the y-axis. Okay, the next little bit of work that we're going to have to do, we had to do quite a bit over here for the vertex. Now we're going to have to find the roots. Okay, so we're going to solve for x. Okay, we already have a, b, and c listed from the standard form, so let's use quadratic formula. x is equal to negative b, so that's negative 7, plus or minus the square root of 7 squared minus 4 times a times c divided by 2 times a. Okay, so what we're going to do is concentrate on the discriminant first. Okay, 7 squared is 49, and negative 4 times negative 2 is positive 8. 8 times 4 is positive 32. Okay, and when you add those two together, you get 81. All right, so x is equal to negative 7 plus the square root of 81 divided by negative 4. Okay, that works out really nice for us. Okay, we're just going to go ahead and simplify that. X is equal to negative 7 plus 9. That should have been plus or minus. Negative 7 plus 9 divided by negative 4, and x is equal to negative 7 minus 9 divided by negative 4. Okay, negative 7 plus 9 is positive 2, and 2 over negative 4 is negative 1/2. So the parabola will cross x at negative 1/2. Negative 7 minus 9 is negative 16. Negative 16 divided by negative 4 is positive 4. So the graph is also going to cross x at positive 4. Okay, let's just put all that together. The roots are negative 1/2, 0, and 4, 0. Now we know where it's going to cross the x-axis. All right, and just think back to the parent function. The parent function is f of x is equal to x squared. So that makes the domain here all real numbers. Okay? The range, in order to determine the range, we need to look at the vertex. Okay? The vertex has a maximum point at 81 divided by 8, which is approximately 10.125. Okay? And if we look at the very beginning here, okay, negative 2 in front of the function means that the graph is going to open downward. Okay? So thinking about the range here, the high point on my graph is going to be approximately 1.75, 10.125. Okay? That's the maximum point. So that means that my range is never going to go above here. It's always going to go below. So y is less than or equal to 81 over 8, which is 10.125. Okay? Now let's look at our sketch. We want to make sure that we get all of the characteristics graphed here. Okay? The y-intercept is at 0, 4. Okay? And the graph is going to cross the x-axis. The roots are negative 1/2 and 4, 0. Okay, so I'm going to draw my x-axis down here. Okay, negative 1/2 is here. 4, 0 is over here. The y-intercept is 4, 0, 4. Okay. So the axis of symmetry needs to go up to about 81 over 8, which is 10 1/4, or 10.125, 10 1/8. And so a rough sketch of your graph, it's kind of hard to sketch this kind of graph, but that's what it's going to look like right there.